So, your river study, that's the field work we've done. You should have now, hopefully, GMTs, background information, and half of your process information at this stage. Alright. If not, make sure that is done for Monday. So, basically, when you're writing up your assignment, yeah, these are the things that you want to include. All right, you want to include the river processes, you want to include erosion, transportation, and deposition, and you want to provide evidence that that is happening. So for erosion, transportation, and deposition, you're talking and you're looking at your pebble analysis. All right, how is the shape changed? How did that pebble get from there to there? Why is it being dumped? What's happened to the river? All right, and you can link a wee bit of velocity in there. As the sort of river gets slower, it's more likely to drop. Think about if you're carrying shopping bags, yeah, and you're struggling, you're going to put the heaviest ones down first, and so on. The river does the same with the rocks. All right. You want to look at factors influencing these processes. So the geology of the land we'll discuss today, the drainage network, climate, relief, so the shape of the land use, forces, friction we'll talk about as well. That links into your pebble analysis, and the velocity. We're going to look at a river's course, particularly if that is the question you've chosen, is how does it match the river's course. And then we're going to look at features of a river that you'll find roughly at each course. For instance, the waterfall we've seen in the upper course. We can use that to talk about it and say, I know this is the upper course because I've seen this feature. Here is how it's formed. All right. So, river processes, yeah, very similar to glaciation. You have abrasion, it's rocks and sediment carried by the river, hit off the riverbed. So that is actually the rocks scraping it away. Very similar to abrasion with ice and glaciation. Yeah, hydraulic action, the force of the river through velocity is forced into cracks. Yeah, it forces air into the cracks. You imagine like a balloon, when you force that air into it, it expands. Same thing happens with the crack. Over time, eventually pieces of the river bank erode away. All right. You've got solution as the kind of salts and acids in the water reacting with the type of rock and wearing them away. And attrition is basically when rocks slowly become more rounded by hitting against each other. Yeah. And then freeze thaw, although like it says not done by the river itself, we did see evidence of freeze thaw up in the Ochil Hills, and we know that is evidence of glaciation, so we can tie that into our assignment as well. Yeah, the sharp angular rocks in the upper course were mainly caused by freeze thaw, but as these processes take place in the river, as we work our way down, we can see that the pebbles actually become a lot rounder. So, erosion and velocity. So the faster the river, yeah, the more erosion is going to take place, right? Because it can carry more, it can carry bigger rocks, heavier rocks, yeah. So the faster the river, the more erosion takes place, yeah. So you can now link erosion into the velocity of your river. So the velocity can be affected by the gradient of the land. So the steeper the land, the river tends to flow faster, pretty obvious. But for some reason, and hopefully we notice this, right, the river actually gets faster in the middle and lower course. Yeah? Although you think it's flatter, it should be going slower, but actually the roughness of the riverbed, right, decreases, so it becomes smoother, so less friction, so the water can move a bit faster. And you've got the Hailstrom curve that we'll come on in a wee second, and you've got the number of tributaries pushing more water into it. Yeah, so there's actually more water and less of it is touching the channel bed where the friction is. Mostly it's kind of going through the middle. Does that make sense? Yeah. So transportation, there is 4 methods of transportation: traction, siltation, suspension, and solution. Yeah. Traction and siltation are for the much bigger materials that the river can't carry, but it either rolls it across the bottom or bounces it along the bottom of the riverbed. Yeah, therefore your bigger materials. Suspension and solution. So suspension is, you know, that when the water sometimes doesn't look clean, it looks muddy and dirty. It's because of the suspension in it. Yeah, and it's tiny wee particles that are just floating along in the water. And then you've got solution is basically anything that is dissolved completely in the water. Yeah. Now there's a couple of sort of pages there that will help you and explain these a bit further. We've already been through them, so again, you can talk about pebble analysis here. You can talk about velocity. As the velocity decreases, yeah, you're more likely to have this happening than this. Yeah, you're more likely to have traction and siltation because the water's not strong enough to carry it, so it's just going to slowly push and bounce these rocks across. Again, the Hulsham curve that we talked about. Yeah, so the graph shows relationship between particle size, velocity, and whether it will be eroded, transported, or sort of deposited. Yeah, so like we looked at any kind of particle size, we can look at the particle size, we can look at the velocity, and then we can kind of decide, is it going to be eroded, is it going to be transported and carried, or is it actually going to be deposited because it's too big for the river at that stage. Yeah, and we watched that video that explained that to us. Do we remember that? So we could use that if you wanted to. Alright, now part of that comes from knowing roughly what type of particles are in the river, and that comes from doing a wee bit of research, and then you can kind of relate it to the Mohs scale. So basically the Mohs scale rates rocks on how hard they are, yeah, with 1 being the easiest to erode and 10 with diamonds being the hardest to erode. Alright, so again, when you find out roughly the geology of Clackmannanshire, you can then link this in and you can talk about how that's going to affect erosion. Yeah, the water probably won't ever erode diamonds away, but it will very quickly erode talc away because it's so much weaker. Yeah, I know there's a lot getting thrown at you here. Once you start to write things up, you will kind of see where things can squeeze in and how they relate once you get your process data finished. So again, slow moving, low discharge. Discharge is just the amount of water in the river. So these things affected here: flat, low-lying floodplain, high level of afforestation, yeah, because of interception. So linking back to our hydrological cycle, which also comes into play with your assignment. Few tributaries and permeable surfaces where the water can kind of filter through, and it takes a lot longer before it actually reaches the river. All right. Fast flowing at a high discharge, you've got steeper hills, high levels of deforestation, so there's a lack of trees, which is less interception. You've got many tributaries, so more water is getting fed into it. All right, more water is going to equal more water, particularly discharge. And you've got impermeable surfaces, roads leading to surface runoff. Now, next to the River Devon, what was the bit where we were at, the River Devon? We stood on it, we walked on it. What was there? Did you all have your eyes closed? It's not a trick question. Concrete. There was a path. We walked on it. Yeah, to jump over the fence, we walked on the path. There was a guy on a bike cycling on it. Do you remember that? Was that a difficult question? Answer it then. How did the bus get to River Devon? What did it use to drive on? A road. Mental. A bus using a road to get a place. Who knew? Right? Again, concrete, impermeable surfaces. The water is going to lie on these and run very quickly into the River Devon. These are things you need to talk about. You're all going to struggle if you can't answer these simple questions. You know, we were there. We've seen it. It's not a trick question about a place you don't know. So, yeah, momentum, gravity, and friction. Again, we spoke about friction. The smoother the rocks, the less angular they are, the faster the water can flow across them. Gravity, steeper the hill, the more gravity comes into play. Think about rolling a ball down a hill. Same kind of idea happens with water. Yeah. So, the river's course, for those of you who may have picked this as your question, and how does the River Devon match up with the typical long profile? Again, like we spoke about yesterday, you've got the upper course, the middle course, the lower course, and then the features of landscape, channel, load, and then actual river features that we will see. Yeah? Do you remember seeing the V-shaped valley? Yes. Mental how we actually went and seen all these things deliberately to help you. Yeah? Meanders, river cliff, do we remember seeing them? A meander is just a turn in a river. Yeah, where did we see that about? At the bit we stood where we done our sort of recordings was a meander. See where we stood where there was loads of pebbles? Yeah, that is a river beach. See the far side where it was much steeper, that is a river cliff. Alright, so you have seen all these features. Now you want to kind of think about how are they formed, alright, so that you can talk about the different processes involved and why they might form at the different stages. Alright, so formation of a waterfall. Yeah, what you have is you have basically hard rock that lies on top of less resistant rock. So again, you're linking in your Mohs scale here of what is the geology of the land. Yep. And eventually the water starts to erode under the less resistant rock here, right? And the hard rock leaves that overhang, and that's where you get that drop with waterfalls. Alright? Because the rock that was here, that used to come across here, right, has now been eroded away. Right? So processes involved, hydraulic action, corrosion is basically abrasion. You get this thing called a punch pool, and anybody who's in my group, that's where the tangerines get stuck in this punch pool because the water swirls round in a sort of circle spiral. So it's actually very difficult to get out of a punch pool. Alright, and we actually seen that with our kind of tangerine as it gets stuck. What happens is then these rocks get swirled about and they erode deeper and deeper, so your punch pool gets actually deeper. Now, you see in the movies when they're like, "Woo, waterfall," and they jump off the waterfall and everything's all fine and dandy. Slightly more dangerous than that because you do have these huge boulders underneath the punch pool, right? That if you probably jump on it, you will break your legs. Anybody ever tried swimming with broken legs? No, nearby. Don't really plan that either. Don't imagine it's easy. Alright, then what happens is this undercut gets too much. So what happens to this hard resistant rock? When it can't support itself, it becomes unstable, it falls, and it adds more rocks to this punch pool. Alright, but again, that'll be on the SharePoint site for us to have a look at. Formation of a V-shaped valley, we've seen. This is basically the kind of picture we've seen. Very, very small river with a V shape going into it. Vertical erosion by hydraulic action, that means it erodes down the way rather than side to side as we get further down the river. Alright. The valley sides are weakened by wearing processes such as freeze thaw. You can then explain freeze thaw and get a knowledge and information mark. Yeah. Basically, mass movement of the material occurs. The freeze thaw, the shattered rock, yeah, the scree slowly moves down. as a river meets more resistant rock, it's very lazy. It won't try and erode through it. It'll meander around it. Again, interlocking spurs are created. And once the river has enough energy, it'll transport away the weathered material. Yeah? And that's when you see your pebble analysis change from more angular rocks to much more rounded rocks the further down the river you go. Formation of a meander, yeah. Basically on the outside of a bend, there is more water, it moves faster on the outside of a bend. If it moves faster, what's happening more? Erosion. Oh, thanks, Jamie. That was good. More erosion because the water's moving faster, yes. So what you get is, you get here, you get deeper water, more erosion, so it erodes, instead of eroding vertically, it erodes laterally, so it erodes that much wider. The slower water here, right, is where rocks get deposited. So that's why on the inside of the bend, right, where we were standing, you can find more pebbles, rather than the outside of the bend where you get more erosion, you find a river cliff. Alright, and then slowly what happens is, yeah, that bend gets much wider. And if you were standing in the water, you would notice that there was kind of trickles of water at where we were, whereas the deeper you went in, it was less trickling, more kind of stronger current and flowing. And that is because the water, yeah, the riffles flow over the deposited rock to make it shallower, so it's more ripply than actually the deeper water towards the outside of the bend. Yeah, and if you went in the river, you would have probably experienced this from first entering it where we were standing, yeah, to those that went in that then had to kind of take the angle of slope here. Much deeper, more water, faster, more erosion occurs, less water, slower, not as powerful, deposition occurs. We follow on that, because that's quite a lot to take in. Has anybody got any questions about everything we've covered so far? No? Everybody quite happy? Everybody now starting to link in where we could squeeze this information into an assignment. If you're not, you should be thinking about roughly where this can go. Think about what does your processed information tell you about the river. Alright? It is your evidence. You can say all this happens, but without actual evidence, your processed information, you're not going to pick up as many marks. Alright?